In first-person shooters, there are two common types of guns: hitscan and projectile weapons. In this Godot tutorial, I'm going to show you how to make hitscan weapons. For this tutorial, I'll be adding on to the first-person character controller I made in this video, but everything in this tutorial can easily be adapted to be used in any kind of first-person or third-person character controller, so don't worry too much if you're using something different. But seriously, watch the video. The first thing we're going to do is go into Project and Project Settings, and in the Input Map tab, write Fire in the action box and click Add. Then press the plus button on the right, select Mouse button, and in the pull-down menu, select Left button and click Add. Next, in order to test that our weapon is working, we're going to create an enemy to shoot. We'll open a new scene and add a kinematic body node. Call it Bad Guy. Add a cube-shaped, collision-shaped node to Bad Guy, as well as a cube-shaped mesh instance. You can tweak the size, shape, and color of Bad Guy however you want, as long as you follow the same basic node structure. Then, we're going to add a new script to Bad Guy. Call it whatever you want. In it, we're going to write var health equals 200. This is Bad Guy's total health. Then we're going to write func_process delta if health less than or equal to 0, queue free. So if Bad Guy's health drops to 0 or goes below 0, then it'll be deleted from the game. The last thing we want to do is click on the node tab on the right, click on groups, write enemy in the box, and click add. This puts Bad Guy into a group called enemy. Next, we're going to go back to our first person character controller. Right click on the camera node and add a new raycast node. Call it aimcast. On the right, click the box to enable the raycast. Set the cast to 0 on the y-axis and something big like -1000 on the z-axis. Now you have a long raycast coming straight out of the camera. Then in our script, we're going to add a few new variables. var damage equals 100, and at the bottom write onReadyVar aimcast equals $head/camera/aimcast. Then we'll go down to our process function and write if input.isAction just pressed fire, if aimcast.isColliding, var target equals aimcast.getCollider. So when we press the fire button, if our aimcast raycast is colliding with something in the game, our target will be equal to whatever the aimcast is colliding with. So for example, if the aimcast collides with our Bad Guy character, then our target will be Bad Guy. Then we write if target.isInGroupEnemy, print hitEnemy, target.health minus equals damage. So if the thing we're aiming at, aka the target, is in the group called enemy, and remember that's the exact same group we put Bad Guy in earlier, then we'll print hitEnemy in the console, just to prove that it's actually working. And we're going to decrease the target's health by our damage amount. Remember that in Bad Guy's script, we gave it a variable called health, which we set to 200. Since our target is Bad Guy, we can directly change that health number here in this script by writing dot and the name of the variable we want to change, in this case health. If you wanted to change a different variable, for example, if Bad Guy had a variable called armor, we can directly change the armor amount by writing target.armor instead. Once you realize you can do this, a whole new world of game dev possibilities opens up to you. So make sure you take the time to understand what I just showed you. Now let's run the game. Here, you can see Bad Guy in front of us, alive and not dead. I've also gone ahead and added a small red dot to the center of the screen to help us see where we're aiming. I won't go into how I did this in this video, but I'll be making a full video on crosshairs sometime in the future, so make sure you've got the bell notifications turned on for when that happens. When you aim at Bad Guy and press fire, the console will print hit enemy, and 100 damage will be applied to Bad Guy. Press fire again, and Bad Guy disappears because its health has gone down to 0. In real life, bullets need to physically travel through the air before hitting its target, meaning there's a small delay between pulling the trigger and hitting the target. However, in this system, the bullet hits the target the moment you press the fire button, with no travel time in between. This lack of bullet travel time is the most defining feature of a so-called hitscan weapon. There is one issue, however. Currently, when you fire the weapon, the bullet, so to speak, is coming straight out of the camera following the raycast. But, as you'll notice, in most FPS games, guns are not sticking out of the middle of your face. Instead, they're slightly off-center because that's how people hold guns in real life. In FPS games, this isn't as big of an issue since the distance between the camera and the gun is relatively small. But in third-person shooters, where the distance is much larger, you end up with weird situations like if your character is standing next to a wall, you can still see and shoot at enemies behind the wall even if your character doesn't have a clear line of sight on the enemy. The most common solution to this is to just make the bullet come out of the actual barrel of the gun instead of straight out of the camera, because then you're only able to shoot things that the gun is physically capable of shooting. shooting. To do this, we're going to go back to our FPS character controller scene, right-click on the head node, and add a new mesh instance node. Call it gun. Tweak its size until it's roughly gun-sized, and with the help of the camera preview, adjust its position until the gun is in a place that looks good to you. Then, right-click on the gun and add a new spatial node. Call it muzzle, and move it forward until it's just past the barrel of the gun. Then, in the script, create a reference to the muzzle by writing onReadyVar muzzle equals $head/gun/muzzle. Then, we're going to go down to our process function and delete all of our shooting code except for the first 2 lines. What we're going to do is create a second raycast using code that fires from the muzzle of the gun to the point where the first raycast collided with something, creating sort of a triangle. This second raycast is what will actually be applying the damage. This way, you avoid the potential for weird geometry issues. To do this, we're going to write var bullet equals getWorld.directSpaceState. I go over how to create raycasts with code in this video, so I'm going to be speeding through most of this. Var collision equals bullet.intersectRay muzzle.transform.origin aimcast.getCollisionPoint. This fires a raycast from the position of the muzzle to the point where the aimcast collided with something. If something collides with this new raycast, we have a collision. Then write if collision var target equals collision.collider. Like before, when the new raycast hits something, target is set to whatever was collided with. If target.isInGroupEnemy, print hit enemy target.health minus equals damage. At this point, we're pretty much done, but there is something I forgot to mention. All of this code is written in the process function, but according to the Godot documentation, raycasting should only be done in the physics process function. I've tested this code in both, and it seems to work no matter what, but to be safe, change process to physics process before running the game. Now, when you shoot, everything looks the same, but now you're shooting from the barrel of the gun rather than from the center of the camera, and everything works out nicely. Congratulations, now you know how to create Hitscan weapons. With it, you can create all kinds of weapons like pistols, assault rifles, and shotguns. Tutorials will of course be made for all of these weapon types and more. However, in the next FPS weapon video, I'll instead be showing you how to make projectile weapons where bullets have real travel time. Anyways, that's all for this video. Don't forget to join our Discord server and help grow the community. And if you like the video, like it, subscribe it, share it, bell it, and comment it. Thank you. Have a nice day.